Population genetics and migration. Here we have a population of native coins existing in Hardy-Weinberg equilibrium. They reproduce through mating, and their style gene determines if they become a penny, a dime, or a nickel. One day, a small group of coins was found in the dryer and added to the larger population of native coins. The local scientist studying the native coins was curious to find out how this migration of dryer coins would affect the native population, so he did some math. The first step to figuring this out is to calculate M, or the proportion of dryer coins after joining the native coins. This is done by dividing the total number of dryer coins by the new total of all the coins combined. This comes out to 0.25. Next, the genotypic array needs to be found so it can be used for further calculations. Let's start with the native coins. There are 18 pennies, so we have 18 of the big A genotype. This gets divided by the total population of the native coins, 30, resulting in 0.6, or 60%. This process is repeated for the dimes and the nickels. It is also done for the dryer coins. To help solve for the allele frequency, we need to solve for both the frequency of big A in the dryer coin population and the frequency of big A in the native coin population. For the native coins, this is done by accounting for how many times big A appears, 2 in this case. It is multiplied by 18 from big A and 8 from big A little a. This is then divided by how many times big A appears to the total of the native population, so 2 times 30, resulting in 0.7333 or 73.33%. This is repeated for the dryer coin population. To solve for the allele frequency, the following formula is used, where M is the proportion of incoming dryer coins, little p is the dryer coin genotypic array, and big P is the native coin genotypic array. The Q prime formula is used then to find the allele frequency of the little a. So after the dryer coins joined the native coins, the following allele frequencies were observed. But what about the new genotypic frequency? We can use the same formula to work it out for each genotype. For example, the formula for big A is shown. This is 1 minus M multiplied by the dryer coin big A frequency of 0.4, which is then added to M multiplied by the native coin big A frequency of 0.6, resulting in 0.45 or 45%. This is repeated for the remaining genotypes. So when comparing the original native coin population genotypes to the new population with the added dryer coins, we find that the pennies or big A has decreased, and the dimes and nickels, big A, and little a respectively, have increased. This shows a shift in favor to the little a allele, or an increase to my pocket change. Thanks for watching.